Good afternoon. My name's Paul Clark. They call me an independent HOCL advisor. Actually, I'm a retired head of facilities management. I retired back on the 31st of March of this year, and I'm presently working with the University of Stafford as a visiting fellow. I'm joined today by Peter Thistlethwaite. Yeah, I can never say that name. Yeah. Peter is the technical manager at MSL Solutions. Okay, our agenda today, what I would like to cover. First of all, I'd just like to give a quick overview of our journey, and I'm saying our journey from my days working with the NHS, which is, as I say, finished just over a month ago. I stood here 12 months ago and talked about an alternative to HPV and UV. And at that point, we were going into the unknown, really, in regards to the use of hypochlorous acid within healthcare. So I just want to give an overview, follow on from that presentation in regards to, the lessons we've learned and where we actually sit at the present moment. I then want to hand over to Peter, who wants to give a really good educational session in regards to the changing regulations for UV and automated fogging devices. And I think this is a really important part of this presentation because, during the period of COVID-19, we saw a lot of pop-up companies come into the final decontamination automated fogging type market, whether that be with UV or whether that be with HPV or other technologies. But I think it's really important now that we've actually got to a position where we've got a standard. And that's not just a standard around HPV, but a standard around UV as well. So, it's an absolute privilege to invite Peter to the stage. He comes here as an independent person, representing MSL Laboratories. So thank you very much, Peter. I'll very much look forward to welcome you onto the stage in a minute. Okay, so where are we? Our case study for 2021-2022. And this was a piece of work that we did as an NHS organisation based in North Wales, the Betsy Cadwallader University Health Board. A very complex name and a very complex organisation. It's an integrated health board with somewhere in the region of a couple of thousand beds. It's got 3 main district general hospitals, and it's got 18 community hospitals as well as associated GPs and health centres. So yes, we started our journey back in about 2020 when we actually tried to look at an alternative in regards to the use of HPV within our organisation. So if we look at our trial, we looked at products that were out there on the market, and then we partnered with Metis Health, and Metis have kindly sponsored this session today. And we started to look at the feasibility of how we actually went through the processes of looking how we could actually kind of convert from the use of the technologies that we already had in place to technology that we wanted to move to. And I'm really, really keen that, there's a lot of presentations going on, and I think there's one tomorrow in regards to, the use of chlorine within healthcare settings and how we need to actually look at how we can move away from the use of chlorine and some of those harmful technologies. And I really am an ambassador in regards to looking at that innovation, how we can actually move away. So the trial that we did, we didn't believe them as we shouldn't. We went off and we actually picked 3 sites across our health economy. We chose 2 acute sites and 1 community site. And we went off and we did our testing with the machine, also with the solution as well. That's Hydra and Solvic, and I'll come on to that in a short while. And we actually then went on to take ATP tests and also swab tests from that particular those particular areas. As I say, at this point in time, it was a bit of an unknown, really. Oh, there we go. So, I think last year I went through the full scenario of the actual testing regimes, but you know, I just want to give a quick snapshot of where we are and what we did. In regards to standards, we found that actually hospitals, as we should find, are really clean places. You know what I mean? It's the actual kind of initial pre-cleaning log results were really kind of encouraging, and it gave us a really good evidence that our physical kind of processes and cleaning that are done on a regular basis within healthcare are really working. So that was so we found that the areas were really clean. We then went on to do our kind of analysis, our swab tests, and we found that in our kind of standard areas, as I would call them, the general ward areas, we actually found that out of 53 swabs that we took, there was only 4 swabs which were actually showing any sign or any CFU count whatsoever in regards to testing that we actually did, which for me was really good, because of the 4 samples which actually showed any count whatsoever, we found that we had mitigating reasons behind that. One was in regards to the back of a remote control for a bed, which was actually had been lying on its back, so actually it hadn't been exposed to the actual hypochlorous acid, and we believe that one of the samples was also kind of a miscalculation in regards to the recording. We put the wrong numbers on the sample, but that was human error. So yeah, really good results from that. And we found that where we tested in one of our HDU departments, actually all the samples, 100% of the samples were actually showing, that there was no sign of any physical matter there or any bacterial growth, which for me was absolutely fantastic. And it just shows that, you know, our buildings are really clean, but actually by the use of additional automated processes, we can make sure that actually they're as clean as we want and as safe as we want for our patients to use. And there, just in graph form, we can actually see that in all trial areas, we only had 4 samples that actually showed anything, and then in the HDU areas, it was 100%. So we were really pleased with those outcomes, and that was what actually took us forward to actually purchase hypochlorous acid at that point in time, and then change from the use of HPV and UV in the organisation. Okay, so what is Messis? What are their products? This is Hydra, a really simple system. You basically put it in the room, you turn it on, and you know, as far as training goes, you don't need in-depth training to actually use this equipment. And that's one of the benefits that we found from it, was that it was so simple that we could actually put it into areas where our normal cleaning staff could use it, so that they could actually use it on a regular basis for automated decontamination, instead of having to have specialist teams that actually went out to undertake the cleaning on behalf. And we saw that during the pandemic periods. You know, we had one occasion where one of our community hospitals waited with a bed that was blocked for 7 days because we couldn't get an HPV team out there to actually undertake that final decontamination process for us. Yeah, so what we found now, that we can actually use it in our community settings as well as in our acute settings. And this is the miracle lotion, Solvic. Really kind, really gentle, but actually 300 times more powerful than bleach. A lot of people say to me, well, you know, if you've got a really good machine like the Hydra machine, Paul, and you've got Solvic, why haven't we had it before? Well, actually, the reason for that is we've never really had stable hypochlorous acid. It's only been quite recent that we've actually had a product which we can actually store for up to 12 months, and know that it's still got that efficacy to actually do the job that we want it to do. So that was really a groundbreaker for us when we actually discovered that there was a stable hypochlorous acid that could be used in healthcare. Okay, so what did we learn? What we learned over the last 12 months? Well, we've learned 6 elements, really. We've learned that it's faster, it's simpler, it's effective, it's pH neutral, it's effective in regards to cost and efficacy, and it's also resistant to to any known nasties that we find in healthcare. So I showed this slide last year, and at that point in time, I didn't really know whether that slide was the truth. I can actually put it on the slide deck now and know that we've actually been through the rigours and robustness of testing hypochlorous acid, testing Hydra in a health community. Yeah, and we know that it works. Okay, so people say, well, yeah, that's great, Paul, but, you know, has it been used in anger? Well, this is the results from just one hospital between July and February of this year, where we've done predominantly reactional cleaning. And we can see that we've done 286 cleans during that period in time. And we've got a breakdown there of the areas where it's actually been cleaned. And interestingly, most of our cleans take place on a Tuesday and Wednesday. So, you know, that's just an interesting fact, isn't it? Okay, and in regards to time, and this is one of the big elements that we kind of wanted to focus on when we were looking at changing and looking at an alternative, because we had times when we had a domestic sat in a chair outside a room for 5, 6, 7 hours whilst we were undertaking a decontamination process. And for me, that really isn't good use of domestic service time. So we can see that just for this one hospital alone, over a month, we found that it related to about 10 working days that we actually gained by not having somebody sitting outside a room whilst we were undertaking those decontamination processes. So for me, yes, it is really fast, it's simple, yeah, and it's a product that we've now invested into as a health board. We started with 8 machines, we've now got 17 that are working across the organisation. Well, I say we, I'm not there anymore, I'm now retired, so I'm sure that they're using them today in the health board. Okay, that's enough around me. I'll hand over now to Peter, who will go on and cover the changes in regulations in regards to the use of UV and automated disinfection. Thank you, Peter.
Good afternoon, all. Can you hear me all right? By way of a quick show of hands, who here uses or sells UV devices or fogging devices? Okay, good half the room. So, effective cleaning is key. Whole room disinfection procedures using chemical or UV light are becoming more and more popular because, one, it uses less staff time, they're quicker, and they've got the lowest risk of human error. If I'm not asking someone to wipe down every table in the room, I can just push a machine and it does it all for me. Why would I use anything else? But there are significant ways that the regulations for these products have changed, and the testing they require to be proven effective has drastically changed in the last 2 to 3 years. First, I'm going to talk about airborne disinfection via fogging device. So this is a chemical product with an automated device that doesn't require a user to operate it within a room. It's the most common method of disinfection for whole room because it reaches all the shadowed areas and reduces human risk. Hydrogen peroxide vapor, hypochlorous acid are 2 key actives in this area, but we've also got things like quats, peracetic acid, lactic acid, a multitude of others. A couple of examples. I did the cleaning show a couple of weeks ago, so these are more for factories. In the past, these devices required a French standard that was called NFT 72281. So this was the method up until 2020. 17272 got released in April 2020, but we were all busy with something else, so no one noticed. This is now the required standard across the whole of Europe. This is all 28 member states plus the UK, and it's also been adopted further afield in markets like Australia, the UAE, India. Both of them are comprehensive methods that cover bacteria, yeast, mold, mycobacterium, spores, viruses, you name it, these methods cover it. But what's changed in this EN method compared to this NFT method that was the principle? So wider range of facility sizes. The test method now uses a test facility from 10 metres cubed up to 150 metres cubed and has a small enclosure test for things like safety cabinets, isolation chambers, things like that, below 4 metres cubed. It now introduces a significant level of interfering substance that the French method did not have. So this is bespoke to the area of use. If you use it in hospitality or use it in a medical area, there are different soiling conditions that you must introduce to your product. Each area of use has a specific bacterial requirement. So if you use it in a medical area, you are testing different bacteria to if I'm using it for a hotel. And now there is the introduction of what is called a distribution test. This is the most significant change to the method, swapping from the NFT to the 17272. The distribution test places 8 coupons in the corners of a facility. In my lab's case, we have a 74 metre cubed room. It's a converted porta cabin built specifically for this test method. You would place coupons in the top corner and bottom corner of a room, alternate on both sides. The coupons face the ceiling or the floor, and they face the walls of the facility, so they are shadowed from your product. And you have to show a 5-log reduction on all 8 of those coupons within that room just to pass this one part of the method. If you don't pass this, then you can't make claims of efficacy for anything else. This is a huge change to the French method. This wasn't required before 2020 for any product. Now you have to prove that machine gets product to all 4 corners of a room and does a significant level of reduction with the level of soiling that you are saying the product works at. And just because a product has passed efficacy test with the NFT method does not mean you will pass a distribution test. People who sell with multiple machines and multiple products have to do this test for every single machine with every single product that they use. So if you have a 4 machine range using only one active, each one of those machines has to pass that distribution test. It can add a new challenge to your manufacturer, and it can add a new challenge to buyers. You have to be aware that this is something you are asking for. If you are using it in a ward within a hospital, you need to be able to prove that it is reaching everywhere in that room. And if you are selling a device, you need to be able to assure a customer that it is doing the same. When do you need to comply? Well, 3 years ago. It got added to the ECHA guidance in 2020. It got added to the efficacy guidance for BPR in 2021. Later on, I'll show a brief example, using a hypochlorous product as an example, where to find these test methods that you need to apply for. That guidance that now every registering country for BPR is using, and the method itself, what you can find in that method for your area of use. Before that, I'll go and talk about UV disinfection, because I've seen a few devices upstairs. I'm sure there's a few people in the room. A few examples of the areas of use. What we're seeing now with these cabinets for reusable parts in the NHS. We've all seen plastic eyewear that we've had to wear, and disposing of them. Now UV devices are claiming to disinfect between every use. Mouthpieces are the same. Then you've got these standing units. They're being used in transport and then in warehouse facilities. This was the cleaning show that was used for. Brief history of UV disinfection. First discovered in 1860, it has been used in disinfection of water since the early 1900s. And since World War II, it's been more and more used for disinfection within hospitals. As of 2022, BSI, the British Standards Institute, released this method that we're going to discuss, which is the BS 8628 2022. So this came out about August last year, was the final publication date. And since then, that has been the minimum requirement for a UV device. Pre-2022, there was no standardisation. If you wanted to compare 2 products, you had to do that yourself, or the manufacturer had to somehow get a hold of a competitor's UV device. You used biological indicators, light meters, and data from white papers that were published in the 1980s. And the market has decided that that's not good enough. You can't just say your product works in 20 minutes and have no test methods that are harmonised to other companies. You can't have testing at 2 labs be completely different, because there's no way of comparing, and there's no way for an end user to understand how good that product is against someone else's in a tendering process. You want something that works and works effectively for what you need. This is what that test method looks like. For a standing unit, you have a shelf that has coupons with an inoculum on it, horizontal to your light source. So that adds a level of shadowing, it adds height, and it adds distance. Before, there was even nothing to tell you how far away your light source had to be in the test method, and then you could claim that it worked. So you could just put anything you wanted as close to the bulb, and at least now we have a standardised height, distance, organisms and log reduction requirements, as well as shadowing from that light source. And then there is a small enclosure test. This is more for these desktop cabinets and for pass-through in food production. In this case, it's a scalpel put into a small enclosure like a desktop device. You would place your test coupons down that surface that you are disinfecting. If it's a shadowed device, so if I have a rebreather piece, I have to put coupons where they would be the most shadowed from that light source within that device to prove in the worst circumstance, am I still getting that 5 log reduction that I require. So it's no longer acceptable to claim efficacy on surface based on swab tests, biological markers and light detectors alone. You must have this test method. Manufacturers have to detail the distance their machine must not exceed. So if you're saying it works at 2 meters, you have to have proved it at 2 meters. If you're saying that you need 1 device, prove it with 1 device. A device must show log reductions that are suitable for the organisms being tested, whether that be 5 log for bacteria, 4 log for spores, 4 log for viruses. You need to show that in principle with a test report. And devices must be tested on which they're recommended for that intended area of use. If I'm selling into a hospital that has a problem with C. diff, you need to show that it works against C. diff. If I'm selling someone that has a black mold issue, you need to show that I've got black mold on that test report. Now, what isn't covered by these standards? And there are a few things that aren't covered. Ozone generators, not covered. Anything that ionises air tends not to work very well on surfaces, and these methods are not designed for that type of product. They're a liquid product with a machine or energy from a light source. Backpack devices, we've all seen them, especially on the news in 2020 and 2021. They are not covered. They are treated as a trigger spray by regulation. That is changing. The method 17272 is being rewritten currently. I'm sat on that writing group. It will include backpack sprayers in the future, but currently it does not, and you don't require this method for a backpack sprayer or a handheld device. A change of device will require some extent of testing. If you are changing your liquid disinfectant, that obviously needs retesting. If you're making it weaker, changing the actives, adding surfactant, whatever it may be, that will require a level of retesting, maybe not all of it. If you're changing the device, you will need to have your distribution test at a minimum retested. You may be asked by competent authorities to retest more than that distribution test. So I'm going to do a quick example of a product and where you find those regulations and what testing you require. So a quick brief, we have an example company as a hypochlorostatic product. Its exclusive use is fogging. And they have a fogging device that they recommend for use with their product. It's intended for the medical area, whole room disinfection for large enclosures, and they want claims against bacteria, yeast, spores and viruses. And they're saying that their product is used after a clean down, so it is visibly clean conditions. You have clean or dirty in a standard. Dirty is gross contamination, and the method uses blood as that contamination. So that would be an example of a surgical ward or post-surgery where the people are recovering and may have those sort of bodily fluids on surfaces. There are several documents that are used in referencing to identify what test methods you require. There's the ECHA guidance on biocidal products. A new version of this was published in November 2022. I'm sure there are many manufacturers in the room that are aware of this document. And then there's 14885. This is more of a lab-based document. This is a guidance document that shows you each test method, what is the most up-to-date version, and both of these are used by competent authorities to decide what goes in your dossier. And then there's EN 17272, which is the method that it would require, and what organisms are covered within that standard. So I'll show you some examples from these. So this is the ECHA guidance. It details under fogging, disinfection products for room disinfection should at least be sufficiently effective against bacteria and yeast. That is what is called your minimum requirement. Anything beyond that is an additional claim that you can put on the label, but you need to show 5-log reduction against bacteria and yeast. All other organism groups and data must be provided. If you're saying there is efficacy against viruses, you've got to prove it. Next is 14885. This very complicated table essentially just tells you the area of use across the top. We've got medical area, and then we've got hand rubs, hand washes, surgical, surface disinfection. That's us. Mechanical actions, that's a wipe. Or airborne. And go down there, and all your claims are 17272. This document is available for purchase on the BSI store. I'd recommend it to anyone who is buying a device or making a device to have this. So it tells you what standards you should be looking for when you are looking at new products, new devices. And then 17272 itself. There are a table within that method that tells you what organisms you need to test and the log reductions you require for that method. On the far side, you can see that we've got organisms for a bacterial claim, and it gives us our 4 bacteria that we must be effective, and it tells us the log reduction we require to see. If someone comes to you with a device and does not have a 5-log reduction against those 4 organisms for medical use, they're not compliant. And that is what governments will be looking for, what the NHS should be looking for, and what manufacturers should be showing in their paperwork. Setting a test condition. So with my, in theory, hypochlorous product, what do I need to tell a lab to effectively get my product tested? I need to know how long it takes to get around a room. So how long am I running that device? How long I maintain that device in operation? And then how long it takes in the terminal phase to remove that product from the air. There is no point in selling a device if it's going to take 12 hours to get that room back after you've used it. You need to know these 3 times. You need to provide SDS data so a lab can give you the correct work, and you need to know what organisms and what conditions your product is being used in. This is how a distribution test is laid out. So you have your 4 clamp stands around the room with coupons facing the floor or ceiling. And then this is your efficacy test. Very rudimentary diagram, but this is the one from the standard. You have 3 test surfaces inoculated with the same organism. You must show a complete kill of 5-log on all 3 surfaces. They are facing away from your test unit. So you have to be able to show that level of shadowing for every single efficacy test that you complete.